We're still studying Chapter 6, Sections 1 and 2. Specifically, this is Goal 4, the ambiguous case, example number 2. So we're asked, and again, to solve a triangle XYZ, and we have our given information. So take a moment, draw just a generic triangle, but label it with the given information. If you've forgotten, side Z should be opposite angle Z. Side Y should be opposite angle Y. Okay, so as I analyze this triangle, I do recognize, and I want to check for my given information, I do have two sides and a non-included angle. So that tells me I have a side-side angle, or SSA triangle. We know that this SSA represents the ambiguous case. So we are going to have one triangle, two triangles, or no triangle at all. And the best way to proceed is to begin by trying to solve the triangle. So if I try to solve this first triangle, I recognize that I have enough information to set up a proportion to begin to solve for angle Y. So the sine of Y divided by the opposite side, 71, is equal to the sine of 75 divided by 51. All right, so if we isolate sine of Y, we would multiply both sides by 71. All right, I want you to take your calculator and find the value of 71 times the sine of 75 degrees divided by 51. So pause the screencast and find that value, please. So you should have calculated that 71 times the sine of 75 degrees divided by 51 is equivalent to 1.34. Now, we know we're solving for an angle, so let's review how to use your calculator to solve for that angle. Remember, because we're solving for an angle, we will need to use inverse sine of 1.34. And you may notice that you have an undefined value. Let's talk about why you've got an undefined value there. Does this mean you've done something wrong because your calculator gave you an undefined message? No, not in this case. Recall that sine of any angle is equal to the opposite leg divided by the hypotenuse. So which means this ratio should be less than 1 because we know an opposite leg cannot be greater than the hypotenuse. So because this value, 1.34, is greater than 1, or if we place opposite over hypotenuse, you see that we're trying to make the hypotenuse longer. So what that means is we have the scenario where we have two sides that are given, but this third side is not long enough to go all the way down to side XZ. And this was one of the scenarios you found during the triangle challenge. So because the ratio for sine is greater than 1, we know that no triangle exists. So let's finish up with example number 3. Solve triangle XYZ, and we are given the given information. So let's go ahead and draw our triangle. Remember, I'm just drawing a generic triangle. Angle Y is 40 degrees. Side Y is 54, and side X is 62. So I don't know the values of X and Z, angles X or Z, or side Z. Before I proceed, I'm going to analyze my given information. I see that I have two sides and a non-included angle. So I do have side-side angle. Remember, side-side angle tells me I have the ambiguous case, which is an indication that we're going to have one triangle, as we've seen, no triangle at all as we've seen, or possibly two separate triangles. So let's go ahead and set up our proportion to begin solving. I have enough information to find angle x first. So the sine of x divided by 62 is equal to the sine of 40 degrees divided by 54. Take a moment and solve for angle x. Pause the screencast and go ahead and calculate that. All right, so double check and make sure that for angle x you came out with 47.6 degrees, and we'll go ahead and round to the nearest degree as per our instructions. So 48 degrees. Okay, this is where we want to stop to check if we have a second triangle. We did not get an error message, so we know that we have at least one triangle. So I'm going to go ahead and draw triangle number 2, labeling it only with the given information. And I just used the non-given information. We only want to use the information that was given originally in the problem. Okay, so this is, recall from the very first example, the relationship that gets us from triangle 1 to triangle 2. And that relationship is that the first angle that we're able to solve for is supplementary to its corresponding angle in the second triangle. So I'm going to give subscripts x sub 2, y sub 2, z sub 2, x sub 1, y sub 1, z sub 1. So that helps me keep the two triangles separate. So x sub 2 should be equivalent to 180 degrees minus angle x sub 1, or 180 degrees minus 48 degrees, which is 92 degrees. No, I'm sorry, it is not 92 degrees. That is 132 degrees. My apologies. So I'm going to place 132 in the second triangle. Let's check to see if we have enough room to create a third angle. All right, so we would say 132 plus 40 is, so that gives me a sum of 172 degrees. So yes, there is space left for a third angle in this triangle. So let's go ahead and calculate that third angle. If the sum of the three angles of a triangle is 180 degrees, then 180 minus 172 is 8 degrees. So now I know that z sub 2 is 8 degrees. And I can confirm that I not only have one triangle, but I do have two triangles with this given information. So one more time, how do I confirm that I have a second triangle? Once you're able to solve for an angle in the first triangle, this angle confirms we have triangle 1. To move to triangle 2, we take that first given angle and we find its supplement. In this case, that was 132 degrees. Once I confirm that there's space for a third angle, that confirms that I do have two triangles. So here's your job to earn 1 bonus point on the next quiz. Before you come to class tomorrow, finish solving for triangle 1 and triangle 2. So go back and solve for angle Z sub 1 and side Z sub 1. And then go over to your second triangle, and it looks like the only thing you have left to solve for is side Z sub 2. So I will be asking for tomorrow the measures and the work shown for side Z1, angle Z1, and side Z2. Thank you.